Okay, let's think about AC voltage dividers. We've already looked at voltage dividers in when these two impedances are resistors, right? So you give an input, and this is a fixed resistor, this is the variable resistor. And if you look at the output in this case, in this voltage divider, the voltage output would be proportional to uh, the variable resistance that we are giving here. All right. So if you write the equations, you would get basically the output voltage would be equal to this. And if we assume that x is very much smaller than 2, then this becomes a linear sensor. We can ignore x here, and we can just write V out is equal to 1 plus x over 2 times V in. Of course, if x is not linear, then you get a kind of a non-linear sensor because there is x in the denominator as well. Now, how does this sensor change when we are using capacitors or inductors? Now, the problem with capacitors and inductors are that the impedance of a capacitor is infinite at DC voltages, right? So if this was a capacitor, this would be infinite and this would be infinite. So you're not really going to get any change. You're just going to get infinite, and this output would be kind of indeterminate. You don't know what you would get, right? Similarly, if these are inductors, the impedance here would be zero, no matter what the physical quantity is and what x is. And so again, you're not able to get any output which corresponds to x. So to make these impedances finite, which is any other value other than infinity or zero, what you would have to do in case we have capacitors and inductors is that this V in cannot be of zero frequency. The V in would have to be of a frequency that is finite, that is above zero. And if that is the case, then the impedance, or if this was a capacitor, the impedance becomes 1 over j omega c. Omega is finite, so the impedance is finite. Similarly, if it was an inductor, the impedance would be j omega L. Omega is finite, not zero, so j omega L is a finite quantity. And then you can use these equations to figure out V out in terms of V in. And then you can have a dependence on X, right? So this is a voltage divider circuit. The main thing that you would have to do for using the voltage divider for reactive sensors is have V in as an AC signal. You can't have DC signals when you are using it for reactive sensors. Okay. Um, what happens if you have a differential sensor? Remember the last lecture we talked about capacitive sensors and inductive sensors that can be differential. So how does a voltage divider work when you have a differential sensor? When you don't have a fixed impedance here, but you have an impedance that again changes with uh, the physical quantity. And the sensitivity is of the opposite signs. Yeah, that's what a differential sensor means. So what do you do in that case? So in that case, what happens is the output turns out to be 1 plus x over 2 V in, which means that there is no x term in the denominator. In the previous case, we said that you can only use the sensor will only be linear if the x is much smaller than 2. But here, there is no such constraint. So in differential sensors, you have much better linearity, and that helps in several ways in using the sensor. We discussed some of those ways when we were discussing sensor characteristics.